Access type. The most hardware designing using VHDL never use the access type directly. The access type allows the designer to module the object of dynamic nature. That means it has to be happen instantly. For example, there is a queue of first in, first out, or there is something that is dynamic variables are available, then the access type has been going to use. Uh, there are when the object declared is to be used in access type, two predefined functions are automatically available to manipulate the object. These functions are new, delocate. The new function locate the memory of the size of the object in the byte and return access value. There is a function delocate, take in the access value and return the memory back to the system. An example of access type is, for example, process have sensitivity is X, type, name of the type first in first out element T, FIFO element T. It's the array type of 0 to 3, that means 4 bit, 4 digit, 0, 1 to 3. Of standard logic, that's name as a line 1, that means total this line is nothing but the line 1. Second line, again type FIFO element access is. Now this is the access type. Is access whom it going to access? FIFO element T, which we already defined beforehand. FIFO element T, which is nothing but the array of 0 to 3. Okay, this completely is a line 2 and line 3 variable. It defined variable by the name of FIFO PTR. Its type is FIFO EL access, which type we have defined beforehand and had a value of null. Variable, second variable, temper PTR. It is also FIFO EL access type and its value also null. Process begin. This much is the description of the process, description section of the process, and process start with the keyword begin. Temp PTR, which we define as a variable of the type of FIL access. Temp PTR is equal to, is assigned the value, this variable is assigned, since it's a variable we will use colon equal to. Now we are using the function new, which we already discussed. New is defaultly available to manipulate the access points. FIFO element T. FIFO element T is defined the type above as an array. Now, for PTR all, now it is an array of 4 bit. So we will write equal to, assign the value of that variable as 0, 1, 0, 1. 4 value 0, 1, 2, 3. Again the same variable can again define with another value 0, 0, 0, 0, that is null. Now you can even access a single bit of this by using temp ptr dot all 0th bit. That means this 0. 0th bit can be assigned as a 0. Now FIFO PTR is equal to temp PTR, and these both are going to point to a same memory location. Okay, and they will have the same data. PTR.all is equal to PTR.all. The FIFO PTR.all is equal to temp PTR.all. End the process. That means they are just acting like a C pointers, which we already gone through in C++ or C programming, pointers and vectors. Okay. That is, let me explain. The line number 2 in an access type is an access type declared using the type declared in line 1. This is the line number 2, which is shown the access type of declaration. Okay. Line 3 and 4 declare two access type variable by the name of FIFO access type. They are the type. Okay. And this is from line 2. And the line number 5, which use the function new, which allowed enough memory for the variable type FIFO element T and return the access value to the memory allotted. The access value return is assigned to temp_ptr, and variable temp_ptr is now pointing on the object type FIFT element T by using this line. Okay. Line number 6 line number 6 is assigned to the object pointed by the PTR. Line number 7 also is another way to assign the value for the access value. And with the using .all, the word .all specify that the entire object is being accessed, and sub-element of the object can be assigned by using the sub-element's name. Another way of assigning the sub-element name is the line number 8, where you use 0th bit to assign some value. Okay. Now, using the line number 9, both temp_tpr and FIFO_tpr can be used to read from and assign to the object being accessed. That means they are pointing to the same object. Line number 10 shows that one object value can be assigned to another using the access type. That means they are pointed by the template is assigned to the value pointed by FIFO TPR. You can see or picturize using this diagram. FIFO PTR is pointed to the same FIFO element which the temp PTR is accessing, or sorry, pointing. Now we will go for the file type. Now this file type. Now file type allows the declaration of object that have file. Now file object type is actually the subset of the variable object type. Now you can see declaration of the file type. You can read the file, write the file, find the end of the file. This is the declaration, file type declaration. A file type declaration will specify the name of the file type and base type of the file. The following is type. Let it be the name as an integer file is a file of integer. This declaration will specify whose name is integer file and is of type of integer. File object declaration look like this. File, my file, object name is my file, is an integer file. Okay, integer file, we already defined what is integer file. Is in the location, this is the location. Okay, declaration of a file. This declaration declare a file object my file that is input file of a type of integer file, and the last argument of the path is the path name of the physical this where the file is located. Okay, an example of file type you can see. Library IEEE, use IEEE dot standard for logic 1164 dot all, entity, keyword entity, name having the entity name is ROM, is having a port, address as an integer type, CS, chip select in as a input standard logic, data, it is output type of integer type, end of the entity by end, name of the entity ROM, architecture having a name, here we name that architecture as a ROM, of entity ROM which we define prehand is begin with the process has sensitive list as adder, and CS any signal change at adder or CS will activate the process, will run the process. We define variable, named it ROM initiated, it's a boolean type, and we define initial value as a false type. ROM data file T is a file of integer. We define this as a file type. Okay, now file of ROM data file, okay, is belong to the type of ROM data file T, is in the path this. Okay, now data type, D type is an array of 0 to 36, that is 64, sorry, 0 to 63, that is 64 bits of integer. Variable ROM data by the name of ROM data of the type of D type. Now this D type is explained above in the line number 4. Okay, variable by the name of I, it's an integer type, assign the initial value as a 0. The process begin with the keyword begin. Between the process and the keyword begin, we have declarative part of process. Begin if, using the loop if ROM initial file is false, which we are already assigned beforehand as a false, then while not end file of ROM data file type of assignment, if it is not the end of the file and I is not less than 64, I is less than 64, start the loop, read from the file and the file data from the initial position. I will increment, since it is a variable, we will write dot colon equal to assign new value, end of the loop, in ROM int equal to, assign as a value true, end of the if loop, and then if the chip select is 1, then data signal has given the ROM data address, else the data is given as a signal of -1, end of if, end of process, end of architecture. This whole example is for the file data type. Okay. Now next what we are going to do is file subtype, which is much more important. Okay. Now subtype is nothing but the subset. Subtype declaration are used to define the subset of the type. The subset can be contain entire range of the base type, but does not necessarily to need to have an entire range. It can have some small range of the file. Okay, where you will have example in the next page. For example, let type is integer having a range this. You can have a subset type. By subtype, natural is an integer range from 0 to positive range. One example, programming example is coming along with the page. Now, this is the example. We will define package by the name of mux type is subtype by the name of 8 value is integer range from 0 to 7. That means there will be total 8 values to the 8 val, and 8 val is the subtype of integer. And of the package mux type, we will use that package as using use work dot mux type dot all library IEEE. Use IEEE standard logic 1164 all. Entity mux 8 is port. Number of ports are 0 to 7, that is 8. Input standard logic. Second, cell in type of 8 val. Okay, 8 val we define in the package. Okay, 8 val subtype is integer range from 0 to 7. Okay, the select is in the form of 8 val q output a standard logic. End of the 8 mux architecture by the name of mux 8. Architecture start with the keyword architecture having a name of mux 8 of entity mux 8 which defined beforehand is begin with cell has of some value, select according to the value of cell, select output signal equal to input I0, I1, I2, I3, I4, I5, I6, I7 after the 10 nanosecond when either cell is 0, 1, 2, 3, 4, 5, 6, 7. End of the mux. This is the example of subtype, and we finish with the chapter number 4. Thank you.